I think this is such a neat multiplication problem of matrices. But before I talk about how to solve it, we do need to talk about uh, how matrix multiplication works. And I'm going to give you an example. This right here is called a 2 by 2 matrix. Okay, and this over here is called a 1 by 2 matrix. So you can see that the number of rows goes first and the number of columns goes second. Well, an interesting thing about the way matrices multiply is this. If I have two matrices, okay, and let's say one of them is, I don't know, some numbers like this, and we try to multiply that by a 2 by 2, which just looks like this is not going to work. Because if you try to multiply a 3 by 1 matrix, which is sometimes written this way, against a 2 by 2 matrix, because these dimensions right here do not match up, you cannot do the multiplication. The result is literally does not exist. Okay, so there's some very concrete rules with matrix multiplication that you might not be used to if all your experience is with numbers like 3 times 5. Those are never a problem. Matrix multiplication very much matters what types of matrices you are multiplying by each other. Those central dimensions have to match. Now, let's try to figure out what the dimensions of A are, because it doesn't tell us. All it tells us is that we're multiplying A times this thing, and you get this thing. So there must be some matching dimensions, and that is our clue that we're going to work on. So I've got a 2 by 2 here. Okay, that's a 2 by 2 matrix, and something is multiplied by it. I'm going to leave some more space. Something is multiplied by it such that I get a 1 by 2 matrix. Okay, well, there's two possibilities. One possibility is we've got a 2 by something. Okay, that's one possibility. And let's examine what would happen if this were in fact true. These two dimensions here would cross out, and you would get, as your result, a 2 by something. Now, there's no way that's going to match. Okay, a 2 by something cannot be equal to a 1 by 2. Just doesn't work. So we know this idea of multiplying our 2 by 2 by something to the right does not work. So instead, let's try this idea. 2 by 2 times something on its left. Now I know the matching dimension has to be 2. So it becomes something by 2 times a 2 by 2 equals a 1 by 2. Okay, well, these dimensions right here, just like before, these ones are going to cross out. And what I'm left with is something by 2 equals 1 by 2. Okay, so the something must be 1. All right, so that took a little bit of work, but now we know that I have a matrix that looks like this. A 1 by 2 matrix. Let's just call it xy. Times -1, 2, 1, 0 equals 5 by 3, or 5, comma 3 in the matrix. Okay, so I know that was a lot of work, but now we have an equation we can work with. And I want to remind you how matrix multiplication works. I'm going to take this row and I'm going to tip it in here like a watering can and multiply each element of the left matrix by each element in the right matrix, rows by columns. So what that turns into is -1 times x plus 2 times y. Do you see how I am matching these up? I'll use different colors here. This row by this column. And that is the first element of the matrix as the answer. So that equals 5. Okay, now I'm running out of time here, so I'm going to be quick. The next multiplication is going to be this row times this column. And I get 1 times x plus 0 times y equals 3. This matrix multiplication was chosen so that one of these things would cross out nicely. You get a very easy solution, x equals 3. Okay? You plug that back into the equation up here, and you get the following. -3 plus 2y equals 5. That means 2y equals 8. That means y equals 4. That means the answer here is going to be this. 3, well, no comma there, but 3, 4.